if the function f of x is equal to 2 tan x plus 2a plus 1 of log of secant x plus a minus 2 of x is increasing on real numbers, then the range of a or the value of a. Since this function is increasing, so we can say that f dash of x is greater than 0. Let us consider here f dash of x. So differentiating with respect to 2x, 2 into differentiation of tan x is secant square x plus 2a plus 1 of log differentiation is 1 upon mod secant x, and again differentiation of secant x, differentiation of mod secant x is, so we can write secant x by mod of secant x into, again differentiation of secant x can be taken as secant x tan x plus a minus 2 is greater than 0. So we can also write here f dash of x is equal to 2 into secant square, we can write it as 1 plus tan square, 1 plus tan square of x plus 2a plus 1 into, so here we can cancel mod of secant x is secant square x, and secant square x here, secant x into secant x is also secant square x, we can cancel them because both are square, and so remaining tan x, so we can write here tan x 2a plus 1 of tan x plus a minus 2 is greater than 0. That is f dash of x is equal to 2 plus 2 times tan square x plus 2a plus 1 of tan x plus a minus 2 is greater than 0. So here plus 2 minus 2 gets cancelled. So finally we can give 2 times of tan square x plus 2a plus 1 of tan x plus a is positive. So here it is a expression, inequality, quadratic expression with the tan x as the variable. And we know that for all x belongs to R, tan x lies between minus infinity to plus infinity. Except the odd multiples of pi by 2, tan x is defined. Let us consider x is not equal to the odd multiple of pi by 2, and the range of tan x is minus infinity to plus infinity. So we can say this tan x belongs to R. Tan x belongs to R except odd multiples of pi by 2. So we can write now, since it is all real numbers and the quadratic expression is greater than 0, it is possible only when the discriminant is smaller than 0. So discriminant is smaller than 0. So we can write here 2a plus 1 whole square minus b square minus 4ac. 4 into 2 into a is smaller than 0. 2a plus 1 whole square minus 8a is less than 0. That is 4a square plus 4a plus 1 minus 8a is less than 0. Or we may also write 4a square minus 4a plus 1 is less than 0. Or we can write this is 2a whole square minus 2 into 2a into 1 plus 1 square is less than 0. So we can write here this is 2a minus 1 whole square is less than 0. And here the square cannot be negative. And since the function is increasing, f is increasing, so we may also consider f dash of x is greater than or equals to 0, for which the inequality here, the discriminant, to make this positive, it can be either delta is less than 0 or delta is equal to 0. So delta less than 0, it is not possible. So either you can consider equal to. So we may write here 2a minus 1 whole square is equal to 0. That is a is equal to 1 by 2. So the value of a is 1 by 2. So we can go with an option C. Okay. So we can simplify here.